I'm a CVM analyst. I'm a data scientist. I'm a machine learning analyst. And so before I start speaking, I want to quickly point it out there that initially at the beginning when I was reached out to, I was wondering what kind of people will I be meeting here? What level in their understanding of machine learning have they gotten to before I come around? So, but while I made a post on my LinkedIn and also on my WhatsApp, someone reached out to me and asked me a simple question that, Philip, what is machine learning? Then, based off what she asked me, is what I structure this lecture with. I just structure a lecture for people who have basically no idea in machine learning, and people who just go online and Google the word machine learning and start seeing robots with pointing fingers and all of that with machine brain, bro. That's not what machine learning actually is, but it's part of it. But we'll go in depth gradually today and see how it goes. So let me just quickly share my screen so you can see my slide. Just give me a second. Okay. Interesting. Okay. Can you see my screen? Please let me know if you can see my screen.
Yeah, I can see it now.
Okay. Good. Thank you. So the topic before us today is introduction to machine learning. But before we start, I just want to quickly give a quote I heard from the movie Hugo, far back as 2012, that stuck with me a lot. It's a quote about machines. He said, one of the actors in the movie was talking with the another actor. He said, I'd imagine the world as one big machine. Machines never come with extra parts. They always come with the exact amount they need. So if the entire world is one big machine, I couldn't be an extra part. I had to be here for some reason. And that means you have to be here for some reason too. Okay. So that is more like the foundation, the founding thought behind building machine. Every single part has a use. So in this conversation we'll be having, I will be referring to machine in the form of a human being. I'll be referring to machine in the form of a computer. Okay. Anyway, anytime in anywhere I put anywhere I try to explain machine and you're not getting it, please call me back so I can get back to explain what I meant by that. So let me just go to my first slide now. So, what is machine learning? Now, when you Google the word "what is machine learning," the first word you get is machine learning is a subset of artificial intelligence. Machine learning helps computers learn and make predictions and decisions without explicitly programmed to do so. So, let me break this down. So, when we say machine learning is a subset of artificial intelligence, it means that artificial intelligence has other subsets, right? The other subset of artificial intelligence are stuff like NLP, that's natural language programming, processing. I mean, then we also have computer vision. We explain each of them. Then machine learning, of course, and several other aspects that we won't be going into in this conversation. So when we say computer vision, mm, I want to make a picture. I want to explain them with real life scenarios for you. If you're in Lagos State, you notice that of recent, if you drive past traffic, like nobody chases you, but at the end of the day, you get a bill. How does this work? So all these traffic cameras on the road, they are trained to be with the knowledge of computer vision to identify plate numbers. You understand? So when you drive past, they capture your plate number and they know you automatically because you have a database with them. So automatically they just create your bill and send it over to you and you make payment for that. So there are different aspects of computer vision as well. There is aspect of let's say you have a store or warehouse and you want to know the number of bags of rice in that store in a warehouse that's so large. You can have computer vision do such statistics for it. It's called object identification and what is it called? Object identification. Yeah, basically object identification and counting. So that's what's basically what computer vision is all about. Then when we talk about NL, that's natural language processing. Now we are trying to make computers understand languages, right? And it is from NLPs that we start to talk about building chatbots and the likes, right? Some time ago, I did a project for a South African firm where we built an NLP algorithm to help us identify different what's it called different official languages of South Africa. If you know South Africa very well, they have about 12 official languages. Not like Nigeria. Nigeria only have one official language, is English. They have over 12 official languages. So we built an NLP model to help identify computer languages. I mean, differentiate or identify languages out of these 12 languages. That's basically what NLP is all about. So when we say machine learning helps computer learn and make predictions, right? Predictions and decision without explicitly programmed to do so. So when we say a thing is explicitly programmed to do a task, this is what I want to come from mind straight up. We're talking about stuff like calculator, right? Calculators are explicitly programmed to do what 1 plus 1, 2 plus 2, 3 plus 3. You understand? So they are explicitly programmed for that purpose. So for machine learning now, we do not explicitly program machine learning, what's it called, machine learning algorithm to do a thing. If machine learning algorithm is explicitly programmed to perform a task, we always call that overfitting. I will get there. I will get there. All right. And one thing as a machine learning analyst or a machine learning engineer, you do not want your model or the algorithm you built to be overfitting. You want it to be what now? To be what's it called? Moderately fitting, not overfitting, not underfitting. So let me just proceed. When we get there, I will explain better. So, So in simple terms now, I'm just trying to explain something. I say, so how do you teach a computer to recognize dogs in the picture? So let me explain how machine learning works now. So say for example, I want to teach a computer or a machine. So when I say machine, I say there be a computer or a human being. All right. So when I say a machine, I'm just having in your mind a human being or a computer or a child. So how do you teach a computer to recognize dogs, or how do you teach a machine to recognize dogs in the picture? So this is how you do it. If you want to teach a machine to recognize dogs in the picture, you show that machine a large number of pictures of dogs. Okay. So say for example, you want to teach a machine to recognize dogs, you start showing the machine close to 2,000 pictures of dogs, right? Now, what this machine or this algorithm or this child, okay, good. For the sake of this, let me just use the word child, please. I'm sorry. I think it's better I put it that way. So for this child sees 1,000 pictures of dogs, right? They start to notice the fur, they start to notice the shape of the ear, they start to know the formation of the nose, right? They start to notice these patterns. You get my point, right? And the good part again, what I'm trying to explain here, what provides machine learning, you are showing them the pictures of a dog, and when you show them the first picture, you call it what dog. You show them second picture, you call it what dog. Third picture, call it dog. Fourth picture, call it dog. These pictures are different, right? And now that child has seen over 2,000 pictures of dogs, right? When you now carry that child now and you go outside, you see a dog going on the street, what would that child tell you? The child will point and say, Mommy, dog. You've trained that child to know dog. But what happens when you now carry that dog outside, that child outside and he sees a cat and he points at the cat and says, Mommy, dog? That's where we are going to. That's an aspect called was overfitting. You understand? You overfitted a child's knowledge with information of dog, right? And now he cannot do well with new information, or will get there gradually. So there was this post that was made on LinkedIn some time ago, and I made a comment about it. Someone made this post, and it was like, okay, it's very difficult for machines to recognize what's it called, this doctor's handwriting. And I made a comment. I told him that man, the most basic machine learning algorithm, like let's say most basic machine learning model, let's say even a basic simple linear regression, can easily identify pictures of what's it called? Can easily identify what's it called now? Doctor's handwriting, the most basic of them all. So I was like, okay, now from this image, can we use machine learning to recognize doctor's handwriting? If yes, how? And if no, why? Who can answer me? I've already answered it already though, but who can answer me? If is it possible to use machine learning to recognize doctor's handwriting? Anybody? Is anybody in the call? Okay, since nobody is saying anything. So it's actually very easy to help to teach to train machines to recognize doctor handwriting. You know, everybody says that doctor handwriting is very confusing, right? But it can be easily recognized by machines. How does that work? So say for example, I take this first picture now. Sorry. I take this first picture, I paste it on my machine on a database, right? On let's say a data set, or let's say a table or a data set. Let me use data set in this case. Place a data set and I call it what now? Paracetamol. I place on that one, I call it amoxicillin. This particular paracetamol, there are different variations. Different doctors can write it in different ways. All right. I paste and paste and paste and paste and label them with paracetamol. If I'm done training that machine to understand doctor's handwriting as let's say close to 13,000 rules of information, right? At the end of the day, I cannot ask the machine bring in a new image and say, okay, what is this image now? Although this doctor's handwriting, it will easily recognize it and say, okay, this has to be what now? Amoxicillin, because it kind of look like what we have here already. So it's very easy for machine learning algorithms to understand, or better still, to identify or identify basically doctors' handwriting. Let me go to the next one. So when we're talking about machine learning now, machine learning can be divided into three sections. We have the supervised machine learning, we have the unsupervised machine learning, and we have the reinforcement machine learning. Okay, I will break them into bits moving on. So let me go to the next slide. So when we're talking about supervised machine learning, okay, under supervised machine learning, a machine learns to make decisions or predictions by training on labeled data set. Now, what do I mean when I say a labeled data set? If I carry, okay, when we were when we are still very young and we were taken to school, they always teach us A for what apple, and you see a picture on the board saying this is apple, and is with the letter A, of course, yeah. So they say A for apple, it shows the picture, B for what ball, it shows the picture, C for what card, it shows the picture, and that is what we call a labeled what data set. So they are showing us apple with picture, showing us dog with picture, showing us ball with picture. It means that every single entity or every single item that is shown to us, it has a label attached to it. You understand? So in that case, we see that data set is what is labeled. And when we want to train a machine to understand that data set and make predictions or make decisions based on that information data set, on that data set, we say that what if that machine was trained using what supervised machine learning. It's supervised machine learning and what's it called algorithm. So supervised machine learning can be categorized into two types. The first one is regression, and the second one is classification. Let me break them down. When you want a supervised machine learning to understand to understand numbers, say for example, you want to make predictions of stock prices. So you take data set, you take data of stock prices from 2020 January 2020 down till like let's say January 2022, right? So when, or let's say you take it to up till like this is September. Let's say you take it up till August of 2023. Okay, and you want to train that machine or that data or that computer with the information from 2020, January of 2020 down to August of 2023, right? Then you want to now use that machine now to make predictions from the 1st of September down to the 30th of September of closing stock prices. Let's say, for example, of Apple. Apple closed stock, or let's say Tesco closing price, right? What you will do is you take in all that numbers from the 1st of January 2020, you train a model. In this case, let's just say we train a linear regression model. Why are we using regression? We're using regression because it is they are numbers, right? We train them, and what we are predicting to are numbers. You understand? We make predictions for those numbers, which is from the 1st of September up to the 30th of September. So that condition is called a regression supervised machine learning. Now, when we're talking about a classification supervised machine learning, now, in this case, we are not making prediction of numbers. We're making predictions. We're making predictions of what? Let's say binary numbers. Let me put it this way. They are you can see them as numbers, but they're not actually integers. Okay, we are coming somewhere. I'm sorry, guys. Just follow me, okay? I should have started from this place. They are what we call data types. Okay, we have integers as a data type. We have what's it called? Um what's the word? Is anybody in the call can give me another data type? We have boolean data types. We have what's it called, d time data types. So there are different data types, integers, objects. The objects now are not numbers, they could be text. Okay, so they are strings, sorry, strings. So okay, cool. So we have integers are considered as numbers. So when you target variables are numbers or are integers, we use regression with provide machine learning. But when they are not numbers, when they are not integers, right? Let's say, for example, I bring I bring a what's it called now? I bring a coin, I flip it, head or tail, right? Now, when I'm trying to say, okay, head, what is the outcome going to be? Is it going to be head or is it going to be tail? Now, I can call that 1 and 0 in my target variable. Even though I'm calling them 1 and 0, they are not considered as numbers because they are not integers. Okay, 1 represents head and 0 represents tail. So those are not considered as numbers. So if you're trying to make predictions of what will happen at the end of so and so, right? It can either be 1 or 0. In that case, we use classification machine learning models. Okay. Now they are multi-class classification. They could be 1, 2. Like I said, in the case of training a die, there are 6 outcomes that could happen. So I could call it 1, 2, 3, 4, 5, 6. Now Those 1, 2, 3, 4, 5, 6, they are not considered as numbers in this case. They are not considered as integers in this case. They are considered as what now? They are considered as what strings. You got my point, right? So those are outcomes. So when the outcome at the end of the day, or the target variable at the end of the day, is not integers, they are not integers, right? Because that we use a classification supervised machine learning for that purpose. Do you guys understand what I just explained? From where we've gotten to so far, is that quite understood? Can we differentiate from regression machine learning models and classification machine learning models? Am I still on this call, please? Elizabeth?
I, Philip, yes.
Okay, good, good, good. Because all I can see is my screen, so I just want to be sure. All right, let me
All right.
proceed now. So when we're talking about unsupervised machine learning, okay. Now remember that in supervised machine learning, I told you that what's it called? The data sets are what they have a label, they have a target variable, which we are trying to achieve. So under supervised machine learning, we are saying that okay, machine learn to make decisions or predictions by training on unlabeled data sets, seeking to find what hidden patterns, structures, or relationship within data. Now let me explain this for you. Now, in a situation where we just throw data at a machine, or we just want to train a machine to find patterns and come up with conclusions. Okay, so for example, um, um, how would I explain this now? Um, okay, just hold on a second. I'm trying to think of something. Okay, let me use a machine learning a movie recommendation system. Okay, let's say we want to. Let's say you just got your phone, you installed Netflix on your phone, right? And you created an account and you open Netflix. Now, what Netflix make their money from? Netflix make their money from their ability to understand you. Not just understanding you. Netflix also make their money from their ability to understand you and also understand your geolocation, the place where you are living in. So say for example now, if you open Netflix in Nigeria, I don't know if Jago Jago is in Netflix. I don't know if it's in Netflix or the other one, Showmax. I don't know which of them is in. So let's say for example, Jago Jago is in Netflix now. If you open Netflix right now, I can guarantee you. Let's say I don't have an account on Netflix because I'm not big on movies. But if I open Netflix right now and I create an account, I'm very sure that I will see Jago Jago among my first words recommended movies. Why will I see Jago Jago? I'm seeing Jago Jago because I'm in Nigeria. If I go to Korea, South Korea, for example, and I open Netflix account there, for sure I won't see Jago Jago. Maybe if I tell them I'm from Nigeria, maybe when I'm creating my account, I wrote Nigeria there, I might just end up seeing Jago Jago, but it won't be top priority because that's a geolocation. That's my point. So unsupervised machine learning is used for tasks like movie recommendation, anomaly detection. I will explain anomaly detection for you very soon, but let me just land with movie recommendation right now. So there are two types of algorithms used in building movie recommendation, right? We have collaborative filtering and we have content-based filtering. So when I'm new to Netflix, for example, I'm getting the recommendation for Django Django because of what we call collaborative filtering. So I don't have any data with Netflix right now. All the data I have are my personal information, who I am, where I live, right? So they just consider that information and they say, okay, this guy have to love Jago Jago. This guy have to love which are Nigerian film again? Mr. and Mrs. I don't know. That's the last movie I watched. Mr. and Mrs. for example, right? This guy have to love this movie because these movies are big and are Nigerian movies. You understand? So those will be recommended to me. Guess what? There is no data sets that contained my name, Philip Ogumola, and also contained the movies that Philip would like. There's no data set for that. So, but this machine was able to identify that okay, because he lives in Nigeria, because he does this, these are the kind of movies he likes. Do you understand my point? So Philip Ogumola doesn't have a labeled or a target variable of what Philip likes. You understand my point? It is through patterns and understanding of my environment that unsupervised learning is able to understand that okay, Philip needs to like what now? Jago Jago. Philip needs to like what the rest, Domitila and the rest, right? Now, when we're talking about anomaly detection, some time ago in Abuja, we heard the news of a supermarket, right, that got burnt down because a little child set fire in the supermarket. Now, we can all go ahead and say, oh, the child was careless and all of that. But all that supermarket needed to do, and every supermarket in Nigeria, all they need to do is they need to build what they call an anomaly detection algorithm on their what's it called, their cameras. So say for example now, if we had built or trained an anomaly detection algorithm on that computer, if that fire, before that fire got bad, right? When that camera notices that the fire is burning there, it doesn't know what fire is. But we've trained the anomaly detection algorithm to see fire and give alarm when there is fire. You understand my point, right? Not necessarily alarm, but the alarm that will notify the security immediately. What will happen is that when when we train that anomaly detection algorithm with so many pictures of what now of fire in supermarket, right? When that fire starts, that's in the control room, they will see that fire, and almost all the screens in the control room will start notifying the what's it called, the person watching the screen that there is fire here. Go get something done about it. You understand? Now all of this can be built with what they call unsupervised machine learning. So there are techniques for unsupervised machine learning. We have clustering, we have dimensionality reduction. Now since they are unlabeled data sets, most of the time we kind of have so many variables, so many factors to consider to make conclusions with, right? And some of these factors are irrelevant to make decision. Okay, now let's say for example, now we want to make a decision if Philip is a good guy or a bad guy. So we start saying that okay, Philip was is has he has his parents, father and mother. Philip went to school. Philip does not smoke. Philip does not drink. I'm just saying, just for the sake of this conversation, not necessarily that people that smoke can drink are bad. I'm just saying for the sake of this conversation, Philip does not follow bad guys. Then Philip like blue shorts. You get my point? Now, that part where I say Philip like blue shorts, is that a relevant variable in determining if Philip is a good boy or a bad boy? No, it is not. So when we're talking about dimensionality reduction, we are trying to remove variables that are not relevant in making decisions with. You understand? There are other factors to look into when you're doing dimensionality reduction. There's also factors of correlation. Yeah, so we believe that if two variables are highly correlated, right, then we have to remove one because, of course, if they are highly correlated, one can stand in for the other. Because at the end of the day, when we have so many variables to try to make predictions with, we end up stressing our computer and what now causing having what they call compute cost, which is also another factor to consider when you're trying to build an algorithm. Now, when we say clustering, in the case of clustering, right, we have what they call the centroid, and we try to bring factors that look like it, look like and look alike into that particular word now, centroid. You understand? So in the case of movie recommendation, for example, I'm in Nigeria, right? Let's say Elizabeth is in UK. Okay. So since I'm in Nigeria, all the movies produced in Nigeria, they come towards Nigeria. All the movies produced in UK, they go towards UK. You understand? So these are the kind of algorithm techniques we consider when we're looking at unsupervised machine learning. So I'm sorry, I can't really go into details for these ones. Let me just jump in this one because of time. So reinforcement machine learning. Now this is one of my favorites, but not much has been. I mean, not much has been done on it that I have followed through. I've never really used this, but I really enjoy the logic behind reinforcement learning. Now, when we say reinforcement learning, God is the biggest programmer in the whole world. That's what we all know and say. And what the reason we say that, one of the reasons we say that is because of reinforcement learning. God trained every human being and animals with the sense of reinforcement learning. Let me explain. So when you were young, and then when I was young, true life story. When I was young, I loved to play with fire a lot. And every time they try to take me out of it, but I always want to go play with fire. So one time there was a hot coal on the floor, and I was so intrigued by it. It looked like fire, of course. So I walked to it and tried to pick it up. My mom said she noticed because I saw the mark on my hand, and she said she noticed it and she wanted me to learn for real how bad it is. So I picked up the coal. It burnt me so bad. I was treated for sure, but I never went close to fire anymore. That is what reinforcement learning is. Reinforcement learning is a type of machine learning where an agent, in this case now me, learns to make sequential decisions through interaction with an environment in order to maximize cumulative reward. So what was my reward? In that case, let's say happiness is 5 and tears and sorrows is -5, or let's say 1 in this case, or 0. My reward at the end of the day was 0. So because I don't want to score 0 anymore, right? I want to score 5. What do? I stay away from fire. Do you get my point? So it's the same principle that dogs are trained with. If you see a dog and a trainer, right, they are trained using the concept of reinforcement machine learning. Okay, so how do we apply reinforcement machine learning? Those of us that play PES a lot, your friend did not come to join you to play the game. So what do? You say you want to play against computer, and you are playing against computer. Computer is beating you 5-0, and you're wondering how is computer beating me 5-0? It's because the computer team are being trained with the concept of reinforcement machine learning. If you play chess online, let's say you are playing chess against a computer, right? It might beat you, depending on the level you are playing with. Now, it is basically trained on what they call reinforcement learning. So I'm going to show you a video right now about how reinforcement learning works. Let me just show you a video. I hope the video plays. Okay. So before I start the video, you will notice that this chicken wanted to be taught something, right? This lady over here is holding a treat for the chicken, and this lady over here is trying to alter the environment where the chicken is in, right? As many times the chicken gets to peck on this what's called, let's call it a pink cardboard, this lady here rewards the chicken. But if the chicken misses to peck on this, it doesn't get a reward. So the chicken will have to keep trying to make sure it's pecking on this so they get a reward. So let me just show you now. So he pecks on it, gets a reward, pecks on it again, gets a reward, alter the environment, gets a reward, alter it, gets a reward, for getting it right, alter it, gets a reward. So even the chicken understands that by the time he gets it right, he gets a reward. So this is what we call reinforcement machine learning, and that's how God trains us. So over time, we understand that the nature of success is totally based on performing some particular task. Tasks like being hardworking, tasks like being what now, being dedicated to your school works. Now, all of these are the environment we are in. As many times as we get it right, there's always a reward for it. So we always try to make sure we are getting it right. So that's basically what machine learning algorithm. Reinforcement machine learning algorithm is basically all about, and that's how games are trained. That's how what's it called? Machines are trained in chess games to play against humans. So let me proceed now to the next. Sorry, let me just. I hope. Just give me a second, please. Let me just move from here. Okay, let me go down to the next. So some key terminologies in machine learning. So we have what they call independent variables, dependent variables, label or target variables, training data set, training data and test data. So let me just explain this real quick. When we say independent variables, we mean variables that are the inputs. They are not dependent on anything. You understand? So Philip wrote an exam. He got A, right? Sorry, that's depends on how well I did in the exam. What I'm just trying to say is they are the inputs you bring to the machine, right? Okay, you want to predict if Philip will do well in the exam, right? You want to predict if Philip will do well in an exam, right? So what do? You bring in how long did Philip study. That is an independent variable. It's not dependent on anything. It's how long Philip studied. If I study for 1 hour, you put 1 hour there, right? What other factor do we look into when someone wants to study for an exam? How much materials does Philip have? 5 materials. Now, all of these are independent variable. You understand? So when we say the dependent variable now, it's now the outcome of all I have done. So how long did Philip study? How many textbooks does he have? Philip studied for 2 hours. He had 5 textbooks. Oh, Philip ended up getting a C. Ademola studied for 4 hours. He has 20 textbooks. Oh, Ademola ended up getting what? An A. So that should be giving you an idea that if somebody now study for 1 hour, have 30 textbook or 50 textbook, there's a chance that what he will do better. You get my point, right? You understand? So those are what we call now target variables or dependent variables or label. But the number of time I studied, they are independent variable. They are more like inputs and bring towards to the machine. Now, when we say training data, now when you're trying to train a machine learning model, or you're trying to train an algorithm, right? There's what we call training data or what we call test data. Training data are what you use to train the machine. They are what you feed to the machine. So you are trained. They are like questions and answers. Questions and answers. So you are trying to tell the machine, okay, if this question comes to you, this is the answer you get. If this question comes to you, this is the answer you get. Now, when that is all you give to the machine and the machine understands, right? That is more like you are explicitly programming the machine to do that. But the way machine understand things is that they understand patterns, right? They understand patterns and they see response. You get my point? So they are not explicitly programmed to give answers like calculators are done are made. This one understands patterns. So you give the machine learning, let's say 1,000 training data. He understands the patterns, and when you now say, okay, give the machine learning model a test data without giving them the what now, the dependent variable or the target variable, the machine can now say, okay, you brought this. This should be the response variable. This should be a target variable. If this comes, that should be a target variable. Do you understand me? So when we say test data, there are data sets that do not have what a target variable. The target variable is left out intentionally for the machine to give response to. You understand? Now, by the time the machine is done giving response to a target variable, now we now carry the machine responses compared to what the original target variable we have to see how well the machine performed. Do you understand? I will talk more on that when we start talking about overfitting. So let me proceed next now. So model selection. Now there are different models that are already that already exist in machine learning. Okay, we have models like linear regression model, we have decision tree model, we have random forest model. You understand? So when you're trying to make selection of a model, you have to first of all understand what is the problem that we are trying to train it to solve. Like I said earlier, the problem could either be regression problem, that's if the target variable is numerical. It could be classification problem, that is if the target variable is not numerical, it is more like a string, right? It could be any kind of problem. So first of all, if you understand the problem, that should now inform what model you're going to choose. You understand? So in the case of stock price prediction, I told you that the target variable, the closing price, which is the target variable in this particular case I'm giving, it's a number. So because it's a number, we use what now? A linear regression model, or we use random forest as well. We can use as many models as possible that are very good in making what numerical predictions, right? So in the case of, let's say we're trying to know the outcome from flipping the coins, or we're trying to know the outcome from throwing a die, right? That particular case is different because right now those outcomes, even though you in a die, for example, you have 1 to 6, those 1 to 6 are not numbers, they are strings. They represent the thing. You understand? So when we're trying to make select a model for that, now we make that consideration. Now we start thinking in line of what decision tree, trying to be a decision tree model, trying to build what now a logistic regression model, not linear regression model right now, logistic regression model. Why? Because we are dealing with what a classification problem. Okay, so at the end of the day, model selection is completely dependent on the problem we're trying to solve. You understand? Now, other some factors you consider when you're doing model selection, you consider model complexity and you consider data size. Okay. Now, in the case of model complexity, now what are we looking at? We are trying to make sure that when we are trying to fine tune our model to do well, right, to make good prediction, we are not overcomplicating issues. Because when you overcomplicate issue, the model becomes so familiar with the training data, and when you give it new data, it gets confused, and we start having a case of overfitting. You understand? Now, for data size, sometimes when we want to build models with so much data, so models are perfectly good for things like that. Okay, there's what called deep learning in machine learning. It's also an aspect of machine learning. We call it deep learning. Deep learning has been is using neural networks, neural network algorithm. They are trained to think like humans. Okay, we won't go into deep learning now because it's on that aspect of machine learning that is really making the world a better place right now. Okay, so when we are having so much data, we most times end up using deep learning to kind of ease the flow. You understand? So I'll go to the next now. Now, what do we mean when we say overfitting and underfitting? I will explain this. Now, in this case, when I use the word bias and variance, when we say bias, imagine I stubborn, I don't want to move. Like I'm a stubborn guy. I can't nothing phase me. I don't switch easily. I don't switch lanes easily. I'm just stubborn. You get. But when we say a thing has high variance, or we say variance, consider the fact that any small thing, I don't move. Any small thing, I don't move. Any small thing, I've moved. Right? That's just let's just use that way to explain bias and variance. So when we say that a model has high bias, a same way of saying that a model has what is underfitting. What does that mean? It means that as new data is brought into this model, it does not switch to understand it. You get my point? So the model came with its own style. Like this is my lifestyle. I'm going straight. So even though I have data coming from different angles, it doesn't flow with it. Meaning it doesn't do an aggregate to know the line of best fits. I'm sorry, I should have explained line of best fit earlier, but that has too many details I don't want to bring to this conversation, so I don't get anybody confused. There are mathematical aspects to this. There are so many mathematical aspects to this, but I don't want to bring that in right now. But trust me, they are very simple if you get it. You understand? So when we say a model has high bias, it means it is underfitting. It is not performing well to select what to select all of this. You get my point? Notice we have a data point here, we have data point here, we have here, we have here, we have here. Now, when a model goes through all of it, right? That is what we think is the best practice. That our model, which is this red line now, you should understand every single what data set word for word. But if we do it that way, It means that we are programming the thing like a calculator, which is what explicitly programmed to perform a task of calculation. But that's not what machine learning is all about. What machine learning is all about, we're trying to aggregate all of these data points and find the line of best fit that answers to all of them at once. Do you understand my point? So what we are trying to achieve is what I have here: low bias, low variance. So when we have high bias, what do we have? If I say high bias, it means that it has what? Low variance. Do you understand? The bias is very high, it's very stubborn, so it's very low in switching its mind to follow patterns. But what we're trying to achieve is the middle one here, which is low bias, low variance. But when we're talking about high variance in this case, now it means that as data point changes, immediately our model switches. It changes, immediately data points our model switches. Now this leads to what? Overfitting. Because if this is the data point we use to train the model, if we now bring new set of data into this now, it will get confused because it wasn't trained to understand that pattern. Rather, it was trained to understand this pattern, which it did very, very well. When you make an evaluation of this model at the end of the day on your training data, you'll be amazed you're scoring 100%. What's it called? You're getting an arrow square of 1.0, which is almost perfection. You get my point? But when you bring it to a new set of data, it gets messed up. So that's what we mean by overfitting. Okay, so overfitting is a situation where what the model becomes so familiar with the training data such that when it is met with new information or new data, it gets messed up entirely. And you don't want that. What you actually want, you want your model to have was low bias and low variance. That's what you want. You get my point. But also at the end of the day, it's also what we call loss function, right? That's what's it called now? The distance between your line of best fit now to your actual to your your predicted. Let me use the word. The difference between your predicted targets from the actual target. You want to make sure that it is very low. It's also called error. You want to make sure you have very low error. I would love to talk about that, but that's also a little bit mathematical that I don't want to show any mathematics on this presentation so far. You understand? But they are actually very simple. Trust me, if you go through training, I'm very, very certain you will grasp all this in the space of 6, 7, 8 months. Okay, so let me really jump to the next slide I have here. So the machine learning processes. So when we say a machine learning process, we're talking about the end-to-end process you go through in building a machine learning model. Okay, so first off, you get your data, that data collection, and data pre-processing. 99.9% of the time, data is always full of rubbish. You get my point? So you want to make sure that before you start building a model or train a model with your data, it is very, very clean. Because when it is not clean, you can misinform the model at the end of the day, and it start to predict rubbish. You understand? So you do your proper data pre-processing. That means you do your cleaning. You make sure that the D types are what they are need, what it is. You also make sure that you are working with only variables that are relevant to making right predictions, right? Then you now proceed to what now? Model selection. I tell you the model selection is entirely dependent on the problem you are dealing with. Are you dealing with a classification problem? Are you dealing with a regression problem? That determines the kind of model you're selecting to build with. Now we also have what they call model training. Of course, this is where you now have to train that model with the data you have. You get my point? So, for example, as a machine learning guy, if I want to use linear regression model, what I have to do is I import what's it called? I import linear regression from sklearn. Don't worry, you understand there are packages that helps you in the way of programming or building your model. There are packages you can use. So I go to sklearn, I get what now? My linear regression model, which comes to me very raw. It comes very raw. So to make it do well with my data that I'm working at, that I've collected, that I've pre-processed, to make it do well with that particular data, I will have to what now? I will have to train that model with my data. You understand? And by the time I'm done training it, I now proceed to evaluating. Now, the way evaluation is done, I will say it once again. I think I discussed about it earlier. I will say it again. The way evaluation is done, right? Like I said, you have your test data, you have your what? You have your train data, you have your test data, right? Your train data contains what? Independent variable and a target variable. Your test data contains only independent variable, right? It doesn't contain target variable because the target variable we intentionally withheld from it. We want to see what our model will predict from testing our model after training it with this trained data. So we train our model with trained data, which is independent variable, target variable. By the time we are sure that our model has understand the patterns in our trained data, we now tell the model, okay, Now take this test data and tell us what the predictions are. So it takes the test data and gives us the prediction. Now we now carry our predictions from our what our model has made and compare it with the original prediction which we will tell from it. When we make that comparison, we can now check, okay, did this model perform well or it performed poorly? Now there are metrics we look at when we are talking about evaluation. We look at metrics like what now? Let's say in the case of regression, we look at mean square error. We look at what's it called? Mean absolute error. We look at root mean square error. We look at R square, the R square, right? There are other metrics to look into when we're talking about regret evaluation in the case of regression. But in the case of classification, we look at metrics like accuracy. We look at measures like recall. We look at measures like precision, F1 scores. Those are other factors. Those are measures we look at when we're dealing with what classification and what's it called now? Classification algorithms or classification models. You understand? So proceeding further now, let me see. I think that's all. So at the end, that's the end. I was supposed to make this slide, but I didn't do that. So that's the end. I will take any questions you have, and if you have any questions, please just let me know. Thank you.
Hello, Phillips. Thank you so much. That was so easy to understand. You broke
Thank
it
you.
down in a way that anyone could. Thank you for your time and thank you everyone. If you have questions, you can just drop them in the chat box or raise your hands and then we'll hand the mic over to you. So any questions? But briefly, before we take the questions, I'd just like to, talk to us about our course, what we offer at Jupiter Academy. So we are looking to actually get started in data science. We actually have a course and we are running a scholarship with Eagle Health that's giving people 60% off our initial prices. So if you know anyone that is interested in data science or if you'll be interested in data science, so you can just take our course with just 40,000 naira. And if it is product management, data analysis, product design, we also do that. You can also join our community where we host or organize weekly webinars. So you can join that as well. And if you're interested in joining or taking our course, I'll share a link with you in the chat box and you can feel that. Basically, that's all. If you have questions, you can just type that in the chat box. All right. Are we clear?
Can I quickly add this?
All right.
Yeah, okay. So I just want to quickly point out something. Um, if you are very much interested in learning machine learning, I will tell you for free that
Mm-hmm.
the best way to go about learning it is to join a bootcamp. You understand? Join a bootcamp. I know a lot of guys who learn machine learning by themselves. It takes quite a lot of effort and a lot of dedication and time to go about that. But when you join the bootcamp, it's very, very easy. You can easily learn from your colleagues, and you have what we call instructors now directly over you that you can ask questions at any point in time. So that's what I just want to point out because, and also, I also want to let you know that it is not difficult. Trust me on this. It is not difficult. Anybody can grasp this knowledge. Okay. I have friends because now when we say machine learning, a lot of people start thinking, oh, engineering, oh, what now? Too many calculations and blah blah blah. Of course, there are calculations, but they are real life situation calculations. If you understand money, give and take. Like let's say you understand that if you buy stuff for 1,000 naira, I mean, you buy stuff for 100 naira, you give them 1,000 naira, you're collecting 900 back. That is machine learning right there. That is how you understand. You should be understanding machine learning. That's the real life application. So it's not like you are doing X, Y, Z. Of course, there'll be X, Y, Z, but right now in this case of machine learning, you are actually seeing your Y. You're not going about finding Y. You are seeing the Y. You get my point. So that's how it works. And you are seeing your X. So that's how it works. So don't think it's difficult. Trust me on that. Join a course. I have friends from theater arts who are data scientists right now. They are doing perfectly all right. I have friends from different art fields who are doing great, not average guys. I'm talking about are doing so well in machine learning. So don't even look at yourself like you will not get it. You will get it. So just join a boot camp, take your learning seriously. It's in a space of 1 year, you'll be amazed how much you've learned. Trust me.
All right, Philip. Thank you. Okay. we have a question from Light, and then she says, "Sorry, did you mention the tools that can be used? I didn't hear that part. If you didn't, what programming language and tools are commonly used in machine learning?"
Okay, I didn't talk about the tools that will be used. Light, I'm sorry about that. So when you in machine learning, you use Python or R language. Okay, but I always ask people to use Python because R is very good for statistics, but not really in the line of machine learning now. I have not used R for machine learning purposes, but I use Python for machine learning, and that's basically what we use, or what I use, or that's the most popular language to use in machine learning. In this tech space, you want to make sure that you are catching up with the pace of things and you are following with the most widely accepted languages. You understand? So that's I would suggest you learn Python when you are going into machine learning. You understand? Other programming language we have to learn also. Not necessarily programming language. In this case, I'll call it the query language is SQL. You also need the skill of SQL. You know how things work now in Nigeria specifically. When you get into a company, nobody comes to give you data. You have to go to the database yourself and grab the data before you go and try to build a model. You understand with Python. So you have to learn the skill of SQL. So SQL and Python is good for a start. Very good for a start. Thank you, Light. I hope that answers your question. Yes, Python. Python. Thank you. Any other question, please?
Well, someone's hand up.